Good evening dear students. In this video session let us learn how to modify the tapered bar into a stepped bar. Let us consider this tapered bar varying in area 1000 mm square to 500 mm square area. Before solving this tapered bar, to determine the unknown nodal displacement, stresses in each element and the support reactions using finite element method, first let us modify this tapered bar into a stepped bar. Now I will modify this tapered bar into two equal parts. There is two steps, step 1 and step 2, and each step of same length 187.5 mm, that is 375 mm divided by 2. Okay. Now consider this step 1. The left side area is 1000 mm square, which is given, and the right side of this step 1 is the average area of left area and right side area, that is 1000 plus 500 divided by 2. The average area will become 750 mm square, that is the area of this mid section of the tapered bar will become 750 mm square. Now right side area as usual 500 mm square, which is given. Now this is, if you consider this step 1, the area of this average area of this step 1 is the area of the element 1, that is 1000 plus the area of this mid section, that is 750. The average area of these two will become 1000 plus 750 by 2, 875 mm square. That I have shown here. 875 mm square is the area of the step 1 in a stepped bar. Next, area of the step 2 will be that is element 2 will be area of the mid section, average area of the mid section of the bar, and the right side area 500 mm square, that is 750 plus 500 by 2, we will get 625 mm square. That is, I have shown for the step 2 the area is 625 mm square. Likewise, this is how we have modified this tapered bar into a stepped bar by considering the average area. Now here 875 mm square is the area of the element 1 and 625 mm square is the area of the element 2, and this is the load which is applied on the right end of this tapered bar, that is 1 kilonewton. Here I wrote 1000 Newton. Once you modify this tapered bar into a stepped bar, let us consider this stepped bar to solve for the unknown nodal displacements, stresses in each element and the support reactions as explained in the previous videos. If you discretize this stepped bar, we will have two elements and three nodes. After that, generate the stiffness matrices for both the elements K1, K2. Assemble these two matrices and get the global stiffness matrix of the order 3 cross 3. Then write the global equilibrium equation Ku is equal to F as explained. And next, solve the equations by applying elimination approach, so that we will get U1, U2 and U3 values, and compute the stresses in each element by using Hooke's law, and the support reactions using elimination approach as explained in the previous videos. Okay, this is how we can modify the tapered bar into a stepped bar. Next, I will consider one more example so that you will understand better. Let us consider one more. This is the tapered bar. Here the second problem. Here in this, you can observe this tapered bar is varying in width, not area, varying in width from 60 mm from 60 mm to 30 mm, 60 mm to 30 mm width. Now here again modify this tapered bar into two steps, step 1 and step 2. Okay, now we got here the step 1, the top width given is 60 mm, and the mid section of the tapered bar, the average width we should consider, that is 60 mm plus 30 mm divided by 2, that will give you 45 mm. Here also the mid section of the tapered bar in the step 2, 45 mm average width, and this is the bottom end, that is 30 mm width, which is already given. How we got this average width 45 mm? Let us take let us prove it. If I consider this as a right angled triangle, tan alpha will give you opposite side divided by adjacent side. Opposite is, if this is 60 mm, now here 30 mm it is given, then this dimension will become 15 mm and 15 mm. Now therefore this dimension will be 15 mm, that is the opposite side, and the adjacent side will be the length of this tapered bar, that is 240 mm given. Hence tan alpha is equal to opposite by adjacent 15 by 240, we will get alpha is equal to 3.57 degrees. Now next I want to know for the at the mid section of the tapered bar what is the width. For that I will consider only this right angle triangle. If you consider this right angle triangle, tan alpha is equal to, that alpha already we have calculated 3.57, tan 3.57 is equal to, let us say this distance as x opposite side divided by adjacent side. We should consider only this much length, that is half of this length, that is 120, x by 120, so that after calculation we will get x is equal to 7.5 mm. This dimension you will get 7.5 mm. Hence the width will be 30 mm plus 7.5 plus 7.5 will give you 45 mm. That's why we are considering the average width, that is 45 mm. You can take average area also. Here in this case width is given. Now as we know, now consider this step 1. Average width will be 60 mm plus 45 mm divided by 2. 60 plus 45 mm divided by 2, average width you will get 52.5 mm. For the step 2, the average width will be 45 plus 30 by 2, 37.5 mm. Okay, now this is the width. Now what is the area? Area you will get, the thickness of the tapered bar is given, that is 1 mm here. Hence the area of the element 1 will be area A1 is equal to width into thickness 52.5 into 1, you will get 52.5 mm square. And next for the second step, second element, the area of the element 2 will be width into thickness 37.5 into thickness 1, you will get 37.5 mm square. So that this is how this tapered bar is modified into a stepped bar having two elements, element 1 52.5 mm square area, element 2 37.5 mm square area of lengths 120 mm each. The same after that this stepped bar is considered to determine the unknown nodal displacement stresses in each element and the support reactions by using elimination approach as explained in the previous videos. I hope you have understood how to modify this tapered bar into a stepped bar. Okay, thank you, take care, stay safe and stay healthy.